Hello everyone, it's Ms. Redmond here with your summary PowerPoints for the Elements, Atoms and Compounds topic. This lesson is called What Are Elements? If you haven't got one already, please can you go and get a pen and a piece of paper so that you can take notes and do any little tasks that I give you as we go along. You can see down at the bottom our learning journey or learning objectives, so feel free to pause the PowerPoint and write those down. What is an element? An element is a substance that cannot be broken down chemically into other substances. Elements are made of only one type of atom. So we've got some diagrams of elements here, and they look pretty boring because they're all made of the same type of atom. So all of the atoms in this box are the same, they're an element. Here we've got some atoms of a gas, here we've got some atoms in a solid state, and here we've got some molecules of a gas, and we'll talk about molecules in a later lesson. Now, most of the substances that you will see around you are actually mixtures. So air is a mixture, wood is a mixture, plastic is a mixture. Even if you have a lump of gold, there will be some atoms of different elements in there. But theoretically, we could have a lump of gold which is only made of gold atoms, and that would be an element. This is the element sulfur. That is responsible for the compound which produces a rotten egg smell. Sometimes at the seaside, when there's lots of seaweed around and it's rotting down, you can smell that sulfury smell. This is the element thorium, which is named after the Norse god Thor. This is gallium, the funny metal that melts in your hand. And this is bromine, whose boiling point is about the same as room temperature. So in the bottom of this vessel, you've got some liquid bromine, and it's boiling even just at room temperature, and it's producing bromine gas. Okay. The periodic table is the table which lists all of the elements, and the elements with similar properties are grouped together. So if we have a look at this column here, we call the columns in the periodic table groups, and we'll cover this in a lot more detail in year 8. This column contains elements which are gases at room temperature, and they're very, very unreactive. So we've got helium, neon, argon, krypton, xenon, radon, and unoctium. For example, helium, we can use it in party balloons because it's so unreactive. It doesn't react with the rubber, and we can even breathe it in and it turns your voice funny. It's perfectly safe to do that because it's so unreactive. It doesn't react with any of the chemicals in your cells. And then if we have a look at the other side, we've got this group here, it's called the alkali metals. Apart from hydrogen, hydrogen's a bit of a strange element, and in year 9 you'll find out why. At some point while you're at school, you'll probably see lithium, sodium and potassium reacting with water. They're very, very reactive, that if you just put them with normal tap water, they have a very vigorous reaction. Rubidium we can't show you because it would blow the glass tank to pieces. And cesium is even more reactive than rubidium, and it's also radioactive, so we can't show you that one. Francium is the element that was discovered by our scientist of the topic, Marguerite Perret, and that is so radioactive that it only exists for a few seconds. If we could get enough francium together, we would probably find out that it's slightly less reactive than cesium, which is weird because we'd expect this pattern to continue of getting more reactive as we go down. But some strange quantum stuff happens around this area, and it means that francium is probably slightly less reactive than cesium, but still very, very reactive. Okay, if you go to this link, there's an interactive periodic table there, and it'll give you lots of basic data about the elements, and it'll also show you their history, like when they were discovered and what they're used for. It's really interesting. Strongly recommend you having a look at that. And it's by the RSC, which is the Royal Society of Chemistry, not the Royal Shakespeare Company. Okay, chemical symbols. So every element has a unique symbol, and the first letter is always a capital. If there's a second or a third, it's lowercase. So here are the first 20 elements. These are the ones which you will need to be more familiar with. The other ones you'll be able to look up from the periodic table. You'll always have a periodic table in an exam or a test. But these ones you need to be fairly familiar with, and we're going to repeat them loads and loads and loads, so don't feel like you need to memorize them now. Although if you feel like it, go for it. So the symbol for hydrogen is a capital H. Helium, because there's already a capital H, we need to put a second letter on there, so that's HE. But be careful because it's capital H and lowercase e, not capital H, capital E. We'll come back to the reason for that when we talk about chemical formulae. It will become clear. So as we go along, we can see that mostly the element symbols are based on their name. So Li for lithium, B for beryllium, B for boron, C for carbon, N for nitrogen, blah, 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 until we get to sodium, which has the symbol Na, which you just have to remember. That is because the symbol is based on its Latin name, which I think is pronounced natrium. It's probably a horrible pronunciation. I mean, it definitely is. But that's why it's got a symbol that's different to its name in English. But the advantage of these symbols is that chemists and scientists working in other languages use the exact same symbols. So even though the word for sodium in a different language will be different, the symbol is still the same. So scientists can talk to each other about the chemical elements and they always know what they're talking about. It's a really useful tool. And just go back to this one about the third letter on the element symbol, that only really applies to the very heavy elements down the bottom of the periodic table. For example, ununpentium, which has atomic number 115. So there's number 1, ununpentiums all the way down to 115. But actually there's only about 92 chemical elements that exist in nature. The other ones have been made by humans in laboratories. Okay, here's a little fun task. If you discovered an element, what would you call it and what symbol would it have? So for example, if I discovered an element, I would call it redmondium, obviously, because that's the kind of person I am, and I'd give it the symbol R because there are no other elements with the symbol R, which is a bit strange because there's an RB for rubidium, RU for ruthenium, RH for rhodium, etc., but there's no R on its own. So I would have that R. So pause the video and have a think about what you would call your element if you want to. Okay, we need to talk about mixtures as well. In a mixture, substances are mixed together, but they're not chemically joined. So that's going to become clearer when we start talking about compounds. So here we have one pure substance, here we have another pure substance, and here we've got a mixture of the two. But you can see that these are in the gas state and they're just mixed together. They're not chemically joined in any way. So we could use a physical process to separate these two things out. Okay, here's some really cool websites that you can have a look at about elements. There's loads and loads of information on the internet about elements. Here's that Royal Society of Chemistry one. Again, that's a really nice one. And there's also a link here to some radio programs about different elements. Here's your summary slide. An element is a substance that cannot be broken down chemically into other substances. Elements are made up of only one type of atom. The periodic table is the table which lists all of the elements, and the elements with similar properties are grouped together. Chemical symbol. Every element has a unique symbol, and the first letter is always a capital. If there's a second or a third, it's lowercase. In a mixture, substances are mixed together, but they are not chemically joined. Thank you very much for listening, and I will speak to you next time.